Hi, good evening, good morning to all participants of this webinar. Very warm welcome to this very important and contextual topic around the essentials of data science and how does it bring success to organizations. As part of the discussion, I am very privileged to have the honor of Professor Nandan Sudarshan. Professor Nandan Sudarshan is a professor at IIT Madras, and he's also a core member of the Robert Bosch Center for AI and Data Science. And based on his past experience working in the high velocity, high intense firms in the New York region, the trading area, and his doctorate from MIT, he's now also very closely working with organizations to collaborate between academia and the industry, and more importantly, helping drive models and algorithms in the AI ML space. We are very honored to have Professor Nandan advise us and also be part of this conversation. Good evening, Professor.
Good evening. Thank you, Balaji.
Srinath Krishnamurthy, another well-known person in the circuit of data science. He's a principal architect with GS Lab. I've had the privilege of knowing him very recently. He's co-authored a book, Building an Effective Data Science Practice, along with Vineet, who is also on the call. A TOGAF certified architect, specializes in aligning business goals to the technical roadmap and data strategy for the clients. Srinath is a computer science graduate from Pune University, and over his 17 years of professional experience has predominantly worked on data mining, predictive modeling and analytics, and covering industries like healthcare, life sciences, CRM, and etc. Welcome. Good evening, Srinath. Good to talk to you and good to have you on the call. Vineet, Chief Data Scientist at GS Lab. Again, he has co-authored the Building an Effective Data Science Practice along with Srinath. Has 2 patents to his name in the US. He has led the effort of setting up the data science group at GS Lab, Great Software Lab, which has successfully executed multiple data science projects in the fields of healthcare, IoT, communication, has led research projects in computer vision and demand forecasting. Vineet is a computer science engineer from Pune University with a master's degree from BITS Pilani. Good evening, Vineet, and it's a pleasure and an honor to have you part of the webinar this evening. First question, and this is probably out of context or out of syllabus, as you may want to call it, the 3 gentlemen on this call. Just before starting this webinar, I was in a conversation with a customer, and there was a very unique question which I thought may be in people's mind. How do you differentiate AI, ML, and data science? And is there a differentiation at all? People think that they could be interchangeably used. Just for the novices like me, if you would like to give some wisdom around what's the big difference between AI, ML, and data science, and is there at all, is there a relationship, is it a subset of each other, is it a superset, whatever it is. Professor, I'd like to have your quick view before I get started with the main conversation on the webinar.
Sure. I want to start by saying you missed out data mining, pattern recognition, and what else? I'm sure there are 2 or 3 more data analytics from that list. But yeah, see, one thing that has happened is you're not going to get a straightforward answer because a lot of these are, again, standards and terminologies that have come to be over time. And it's also about who is using the word. The way an academic would use the word artificial intelligence is completely different from the way industry uses it today. But to still make a meek attempt at answering your question, and I'm going to give you a mixed answer somewhere between academia and industry. So artificial intelligence is really about showing intelligent behavior, how human beings subjectively describe something as being intelligent behavior that is being carried out by an artificial agent like a computer. So this could, in some sense, be multiple complex views of information theory, of theories on intelligence. It could, in some cases, even be rule-driven. There is no statement on, hey, this is not data-driven, this is rule-driven. If it's intelligent behavior that is personified by an artificial agent, that would broadly be artificial intelligence, where the word intelligence is subjectively human-defined. So a human being terms it to seem like an intelligent behavior. That agent answered this question intelligent. It could be rule-driven, machine-driven, right? However, machine learning, which is seen as more of an applied subset of artificial intelligence, is very specifically the fact that an algorithm reacts to data as opposed to traditional rule-based programming. So instead of saying, if you see X, behave this way, we want to push the barriers on that and say, if instead of explicitly programming rules by an individual or a human being, you want to react to data. And so machine learning is broadly this notion of, rather than traditional programming, reacting to data or being data driven. Data science, is again a broader umbrella, but it's a broader umbrella that has everything to do with data related work. So for instance, something that I would put in the bin of data science but not into machine learning is the data pipelining process, or how do I make the data more useful for algorithms. So for instance, machine learning might not be concerned with data pre-processing, whereas data science is a much bigger umbrella where all of these pieces could fit in towards a useful solution for an organization or a research problem.
Oh, thanks, Professor. Srinath, quickly, your take.
Yeah, I think Professor covered most of the relevant points. Machine learning, the way we look at it, is also, it's one step in a kind of overall data science process, if you will, where the initial steps would involve data capturing, data preparation, and then eventually after machine learning, the models need to be deployed in production. So data science kind of encompasses this entire process. Like Professor said, the main difference is within AI, there's a rule-based and a data-driven approach. One example of this is particular chess playing engines. If you look at the engines which existed in the around 2000s, late 90s and 2000s, they were primarily rule-driven. So a programmer would encode rules that in certain chess positions, depending on king safety and the kinds of pieces, these moves are optimal. The newer ML algorithm-based approaches, which primarily try to determine the best moves based on data of past games, is more of a ML or data science approach to AI. So that just wanted to provide a kind of common example of what Professor was saying.
Vineet, as a warm-up, what would you suggest?
Yeah, so Balaji, actually, this is a very common question, and that was the reason we had to start our book with this, precisely this, where we disambiguate these terms AI, data science, ML, and we gave a very simplified picture. Professor gave a more detailed answer, but our picture just says AI could be rule-driven or data science-driven. So rule-driven, another example I'll give is emails. You want to detect spam, so you do so based by coding some rules. If it is from a certain email address, certain domain, what are the kind of words it could have. So you implement those rules. The other approach could be where you classify a mail as spam based on past email data that you have, which some of which are spam, some of which are non-spam. And this data science approach, as the name suggests, it involves experimentation repeatedly to create models. And every iteration of the experiment has different stages: data capture, preparation, and machine learning is the step where the actual model gets built. So it's in our simplified picture, AI could be rule-driven, rule-based, data science-based, and machine learning is a step inside the data science approach.
Nice. Thank you, Vineet. Thank you, everybody, for clarifying that. Maybe even a novice like me now can get a better handle of it. But going back to the same and taking a cue from what you just said, Vineet. So do you really see applicability of some of this in day-to-day life and in business scenarios? Are you seeing some practical applicability of AI, machine learning, data science, especially data science in some of the business problems of today? Have you come across some scenarios where it has really augmented and helped us to take some intelligent decisions? What's your view?
Yeah, definitely. I think, now the whole world knows AI is driving things everywhere. So some of the practical examples that we ourselves have worked on, data science is being used to predict health condition based on just a few seconds of voice sample, or people want to optimize their processes based on predictions coming from models that have been built using past data. So for example, if you can predict the sale at gas stations, you can plan the inventory replenishment in an intelligent way. data science can extract the action items from all your emails, from the host of emails and social media comments that you receive every day. So all these we have actually helped build, and we see more of such examples that customers bring to us where they want to achieve similar things, and they are successfully doing it.
Oh, nice,
And
nice, nice.
Most of it is data science. But we also have the rule-based systems, and one of the approaches we suggest to our customers is till they collect enough data to build good models, they could have rule-based systems in place. And once they have the data, they build models, they can replace the rule-based systems with data science-based systems, which could be more accurate in some cases.
Nice, nice, good. Professor, you playing a huge role between academia and industry. Where are you seeing the practical applicability and adoption of some of these techniques of data science and ML in day-to-day life for solving some business problems?
So, I mean, in a sense, Balaji, what is happening is a slight change in mindset. So, to directly answer your question, we're seeing it everywhere. We're seeing it in almost every domain. I would say most domains, with the rare exceptions that people have spoken about, such as nurses in healthcare setting and so on. So where there is a human touch that is greatly needed. In all other situations, we're actually seeing data science. So I can't think of really any domains or verticals where it's broadly untouched, and there is no specific functional application. Even if I start breaking things down by image recognition, audio and sound, and transactional data and so on, again, you're seeing data science proliferate and all of these things. But a part of this balance is a more fundamental one. It is a more fundamental balance between empiricism and rationalism, right? And this has existed time immemorial. Some people say it should be done because in principle it should be done this way, versus some people say, show me the data. There should be a rational way in which I do something, see the outcome, and react to that outcome, right? And well, data science really picked one side and made it very easy to do the second, right? But you are always going to find that battle. So what we are seeing with this increased adoption, I would say, is a change in the mindset and DNA of many companies that are saying, no longer am I going to value great ideas, but I'm going to value testable ideas. So enough with this hero worshipping CEO business of, this is an amazing genius idea, but show it to me, testable ideas. And companies that are in the forefront, your Amazons, Googles, which are moving in that direction, then they're going to find applications for data science and AI ML in every domain, pretty much.
But on the same topic, Professor, one question which keeps coming to my mind always, and this is my personal question, is do I say that I have to use AI ML and then go find the problem? Or do I find the problem and figure out whether AI ML is applicable there?
Yeah, so I think that's a great question. And for me, there is no doubt that it's the latter, right? With almost anything, I would say, even beyond AI ML, even if tomorrow there's blockchains and there is different things, you never want to be hammer first, right? I have a hammer, so everything looks like a nail. You want the demand pull rather than the supply push. And I think that's a fair business principle across the board. But there also needs to be an openness, is my point. In a sense, you have a problem and there are two ways of handling the problem, right? Your intuition about it or show me the evidence way of it. And there is a lot of hesitation, for perhaps good reasons to experiment. Like I'll give you an example. To go with the default option seems fine. To go with the expert's judgment seems fine because you can point a finger to someone. Can you point a finger at an algorithm? It's harder. So there are lots of ethical and social reasons why there is hesitation. But I think that is the right thing to overcome. And organizations that do overcome this do really well. But it's no doubt in my mind that you start with what is the business problem and what's the best way to solve this business problem. And whether you call that AI or ML, I'm fairly certain that you would be comfortable by saying we should solve it with data. And so data-driven decision making, which is the roots of empiricism, is what AI and ML are ultimately pushing for. The tags might change as it goes.
Nice, nice. Well said, well said. Srinath, your view, where do you see these practically applicable, especially with your background of not just being a data scientist, your enterprise architectural background, your ability to look at things across the enterprise and not just restrict yourself to a business problem. How do you see the applicability of this evolving fantastic instrument, if I may call it that way, to solve business problems and being embraced to solve business problems?
Yeah, so clearly in the last 6 to 7 years, the possibilities have immensely been increased. So I think earlier, under the umbrella of data mining, people used to analyze data to influence business strategy, for example, like which business model to follow, and those kinds of things. Now we are seeing increasing adoption of these data-driven methods in optimizing business processes through data science models, as well as we're increasingly seeing technology products that rely entirely on data science models. So the example that Vineet gave of detecting health conditions from voice samples, or various other products which depend on computer vision and NLP, for example, monitoring traffic, crowd. All these are now increasingly common, primarily because of the advances in AI under ML umbrella. So I think, like Professor said, it's kind of pervasive these days, and we are also often seeing people approaching it the other way, like Balaji mentioned. So I want to use AI. Where can I use it? which is probably not the best way all the time. But I think it does help for technology leaders to be aware of the new possibilities which have opened up because of AI, so that then they can relate it to their business as appropriate. So yeah, I think it's increasingly useful for enterprises. And Balaji, I think in your question earlier, you also mentioned augmentation, right? So how AI is augmenting human experts also is evolving. So I think experts using AI models for their decision making is one kind of scenario, but there are also projects where we are seeing that past decisions of experts can be used to create models, and those models can be offered as a service. So even enterprises can start exposing their expert models as services. And the other way of augmentation is when experts differ in their opinion, an AI agent can help kind of break the tie. So one research project, for example, we've seen is when experts differ in the diagnosis of prostate cancer from biopsy images. Different experts can have different diagnosis from the same image. In some cases, the same expert shown the image at different times may diagnose it differently, like the grade of cancer. In these kinds of cases, an AI model which is trained to be objective can act as a tiebreaker also between different expert diagnoses. So these are different ways in which we are seeing the AI augmenting humans.
Very interesting you say all this, right? Because I will come to a practical scenario which I had one of the, and I'm sure, right, you all appreciate that such technologies have naysayers, right? So there were a couple of them who were pretty vocal about it in some of the conversation. I'll come to that. Let's go to the poll question, because there is a significant amount of audience participation already. In the recent times, is one of the highest attended webinars from what I see. Which is, I think, speaks for the interest people have. So let's bring up the poll question. Do you really think, Vineet, AI has become mainstream? And of course, I'll ask the audience to also poll. It's a straightforward yes or a no, but it's some question which has been in people's mind. Like, for example, earlier days, web services were there, then microservices were there, then containers came in. They all have started to become mainstream. Now, similarly, has AI become mainstream? I would request the audience to put in their poll, and we'll just give them another 10 seconds, and then we'll close the poll. And then I would probably go back to the panelists. So we'll close the poll now, and let's see what the response is. it was definitely much better than what it was earlier. Definitely an yes. It's not a resounding yes, but a definitive yes than what it was when I did a similar webinar 6 months back, where it was the other way around. So definitely mainstream seems to be the answer which the audience feels. What do you guys think? And when you think about it, I'll also pose the question the naysayer brought it up, right? Which is probably a little interesting. When you say mainstream AI, does it integrate and augment with human emotions? Because human intelligence does automatically have an integration with emotions. Does artificial intelligence have? The question which I was asked by a very large automobile giant, one of the leaders, technical leaders in the automobile space, was if there is a driverless car, and I'm sure you heard this multiple times, driverless car driven by AI based solution, and he's at the crossroad and he has to take right to go, but there is a vehicle in the opposite direction which has broken the lamp, the red light, and he's taking a turn. So now you have to move the driverless car driver has to move the car left so that it's not getting hit by the person who's broken the rule, to be safe for the passengers inside. But if you move left, there is a pedestrian walking. Now, what does the car do? Does it go left and kill the pedestrian to save your person in the car? Does it go right? What does it do? So these are questions which the naysayers ask you, right? So I just want to get a view from all the three luminaries here. If AI has become mainstream, what does it mean? How does it be called as being mainstream? Professor, your views?
Sure. So I think, Balaji, I think that's one example, right, where you'll have to get into human ethics and emotions. There are a lot of things that AI can and does do which have nothing to do with this. And that's perfectly fine. If I need to better find defects in a piece of metal, I mean, I can create a reward or objective function that has very little to do with human emotion and still have a perfectly functioning AI. Now, even on things where you are interfacing with human behavior, there is a whole field called human in the loop AI, right? Where you learn from humans, that is one part, and you augment humans, as Srinath was saying. And both sides are actually a very active area where AI is becoming mainstream by integrating with the human. Now, you are always going to find some ethical questions like the one that you said. In fact, the one that you said is famously often called the trolley problem, and it has been in philosophy for well before the words machine learning or AI even came into existence, where the trolley is going down and someone has a lever. So just if you Google trolley problem, you'll see that this problem has always existed. The interesting thing is that in the past, whether you solve the trolley problem or not, first of all, for philosophical problems like this, you're not going to find solutions. There's no yes or no, right? There are perspectives. But whether you solved it or not, life went on. But now all of a sudden, we are putting much higher benchmark on AI and algorithms. And a part of that is not because the ethical problems are exacerbated by AI. It's the fact that culpability, who do you blame when things go wrong, is a little unclear. And that's one of the reasons. But as I say this and open more questions than giving you answers, these are all very active areas of research in AI. These are all problems that both not just academia is dealing with, but entire legal system is dealing with, and human beings as we interface with them are dealing with. So the amount of noise around this itself makes me feel like this is mainstream. It's not a new problem that is brought forth by AI. It's a problem that has always existed. We are just forced to settle the problem now.
Understand. Srinath, your views?
Yeah, so I think I completely agree with Professor. I think as the naysayers' viewpoints become more subtle and more involved, I think it's an indication that things are probably heading in the right direction. I mean, the more complex their scenarios become, it's an indication that problems are getting solved. So it's even more complex settings where issues are probably going to arise. And I think all these kinds of philosophical questions, I always recollect. I'm not sure if you're familiar with Asimov's works. Isaac Asimov. He had a series. One of the books was I, Robot, and basically he sets out 3 laws of robotics, and then situations occur where the robots enter into some paradoxical situations, right? So even from early 1900s, all these kinds of scenarios have been highlighted, and they will continue to be highlighted, and the industry will need to continue to step up to solve those problems in an appropriate manner.
Oh, very good, very well said. We need one extension of my question as a nuance is, would you, while considering data science, ML, AI, would you have like a guideline as to the do's and don'ts of it and use it while you're trying to address this emotion part of it? Would you go a little extended in your response to my question about the emotions and how it has become mainstream? Would you provide guidelines or an SOP type of thing for implementing or embracing AI ML in the situations you've seen that people have embraced it?
Yeah, Balaji. So about this question, whether the AI car will save the child or not. So I would say AI is as good as the data that you have trained on. So if you train it on similar situations, so the models will slowly learn that they have to save. It has to save the child. Human life is more precious. So it never feels the emotion, but if you have trained it, it might take the right decisions, and it slowly learns as you improve the training. So one similar example that's often given is if a person is watching a play, whatever is being shown, the person who is watching, the observer, he goes through emotions. But as compared to an observer who is watching with emotions, if there's a machine that's also watching the, if we can say, watching the play, so it will never feel the emotions, but it could be programmed to shed tears or shake while looking at the play. So because it has been trained to do that, though it never really feels emotions. So even the AI models, though they will never feel the emotions, but if we can train them the right way, they might still end up taking the right decisions. And to do that, you of course need to train it with all these kind of situations. Yeah, so in reinforcement learning, where your model learns through rewards and penalties, so you can adjust those so that it knows saving human life as reward, or not saving human life as a penalty, and so that's how we can approach it. Uh, if we want AI to take actions that seem emotional.
Okay.
Yeah, actually,
So,
yeah, so just around reinforcement learning, I think professor would have more thoughts as well. But I think there's increasing research into how reinforcement learning can be first done in a simulated environment and then be applied in the realistic world. So that's also very interesting area of research. Probably, professor, you can add more to that.
Sure. No, no. Thank you, Srinath. Before we speak about reinforcement learning itself, I wanted to take a slightly stronger statement, and I'm going to quote someone out here. And perhaps this addresses a broader fear mongering that happens with AI/ML. Right? Is it doing the ethically correct thing? By not understanding human emotion, is it artificial? Are we going to create killer robots? And there is this academic, and I guess he's in industry also now, by the name of Andrew Ng. He's been in many videos and lots of courses. And he had an interesting thing to say about this. So he said, when thinking about fearing about killer robots because of AI, it's kind of like worrying about overpopulation or pollution in Mars before I've even landed there. And for me to kind of productively work on the problem, I need to land in a place. So I might not be very useful in solving some of these ethical dilemmas when you're so far away from reality. It almost seems like being a naysayer for the sake of being a naysayer rather than actually dealing with the problem. So I just thought I'd provide that slightly stronger response to this naysaying. But no, absolutely, building on what Srinath has said, things like RL and human in the loop learning, and I would say more broadly, even any kind of prescriptive analytics, does give the kind of flexibility to mimic humans, learn from humans, behave like humans, control reward and punishment. In short, we have as many levers as a human being does to make an ethical decision, and yet we see a complete lack of ethics in human beings, and objectively also, if things like racism in loan dispersal, credit dispersal, has historically existed, and sure, if you take that data and learn from it, an algorithm is going to be just as bad. Routinely, we show that driverless cars can be as safe than people falling asleep on the wheel. But for good or bad reason, we're going to use very different benchmarks on AI versus human beings, because I think it comes down to culpability ultimately. And that's a much broader question, Balaji.
No, makes sense. Makes sense. And I don't know whether I triggered the right thing or the wrong thing. There's a lot of response for the question which I asked from the naysayer. One of them saying that why can't the car brake rather than move right or left? And I think the discussion can keep continuing, right? To your point, Vineet, should it
To
save the
all
child?
of those, I'm sorry, to all of those, go Google the trolley problem. There are constructions of the problem for which you will not come up with any answer. And almost any answer will make you seem like a horrible person. Philosophy has been beating this problem to death for years.
Right. While we bring up the next poll question and quite a bit of response from the audience, what do you think, Vineet? Where are we with reproducibility with regards to data science? Is data science and models reproducible, or are they unique all the time?
So actually, reproducibility is one of the factors that needs attention while models are being built. Because you would want, if you have built your model that's working a certain way, you would want to reproduce it. And there are a few things that need to be taken care of while the models are being built, in terms of how you are storing the data, what random seeds you are using. So it needs a lot of attention. Otherwise, each time you're running your notebooks, you get different models. So, but yeah, if care is taken, you can get reproducible models.
All right, thank you. Another question. Go ahead, Srinath.
Hey, so just to add to that, since we are talking in the context of businesses here, so one of the things being observed is, although data science is kind of scientific discipline, the focus on reproducibility of experiments and peer reviews are within an industry not as rigorous as it's usually in the scientific fields, in my view. So I think the past couple of years, there are tools which have come up to address this. The whole notion of feature stores, which is a new category of tools, for example, is aimed towards enabling reproducibility of experiments and these kinds of aspects. So it's a very important topic, and I think the overall, even the data architecture and the technology leaders, it would help if they focus on this with the data scientists in an organization.
Agreed. Srinath, I'll stay with you. There is another question. In principle, it should be possible to specify a computation to sufficient detail that anyone should be able to reproduce it exactly. But in practice, there are fundamental technical and social barriers to doing so. Where are we with this issue in the context of AI-based computing? Any suggestions, any responses to that question?
So in the question, when they say social barriers, for example, I'm not entirely sure what.
For me, that could be the same emotions, right? I mean, does it augment, was it replace, that type of social emotion? There are, of course, very technical challenges, which are barriers are going to be there to get started, what right platform and so on. So I think there are a significant amount of starting barriers which come up when you talk about AI, when you talk about data science, compared to writing rules using sufficient amount of detailed data. That's, I think, the question.
Okay, got it. So I think, yeah, these kinds of hurdles, also in the context of reproducibility, would exist, and I think they are more challenging in products or platforms which are operating in the consumer area, like out in the real world, like driverless cars, or products which are in the consumer's hand. Within the context of an enterprise or a business, I believe those are hopefully lesser challenges because it's in a more controlled environment within the enterprise.
While we continue with the conversation, we'll bring up the next poll question. But again, this is becoming interesting, right? What is needed to get started on AI? Is it people? Is it problem statement? Is it awareness? Is it data? Or is it all of the above? I would request the audience to give their response to this. But if I go around, Professor, what is the most critical thing out of the four?
Let me tell you what I'm going to throw away, and you're going to hate me for this. I'm going to throw away data. Okay, so I definitely think I don't think you need data to start data science. I know it's an unpopular opinion, but I'm going to say it. I really think people and problem statement. I guess awareness. Yeah, you can't say no to that. The first three probably.
Understand. We'll now close the poll question. I hope the audience have provided their response. Vineet, quickly, what's your view? What's your take?
I think I would, in my opinion, I would say awareness is the most important.
Okay.
So if you have awareness, we were talking about AI being mainstream. I think we already see a lot of adoption and other people are curious. And if people are aware, I think there's hardly any business problem where AI cannot be applied. And once you have awareness, then there's a natural sequence of things that you might do even before you have data. Like Professor said, data, even in my opinion, is not essential. You can identify areas where you can where data science can help you. And like I had earlier mentioned, you could implement a rule-based system to begin with. That gives you a window to collect the data, get the right people on board, build the team. Then you decide your culture, apply the techniques that are relevant for you. You set KPI, you decide KPI for measuring progress, because otherwise data science projects can keep on running for years without progress. And eventually when you have the model, you have tested it, you can replace the rule-based system with the model. So to begin, you began with awareness, in my opinion. So I would say that's the most important, in my opinion. And people get added later, maybe chief data scientist along with the domain expert. They are the first people who define the problem statements, the problems that can be solved. So all three come, and then data is the last one to come. So I agree with Professor. The first three are important. Yeah.
Very interesting that all of you throw data away. So we'll close the poll question and see what the audience has to say. But Srinath, quickly.
Yeah, so I think awareness is first. Second is either problem statement or data. One of the two is fine, the other will follow. And yeah, finally, depending on these people.
Right. The audience picked problem statement as the first, data as the second, awareness as the third, and then fourth as people. But that's a fair point from the audience, and I'm sure they're going to change what they're going to change, how things are progressing. We'll come to one last question and then probably have some sub questions. Is AI, is data science ready to become mainstream and solve mainstream business problems? And when I say that, I want you to keep in mind saying that I have a mirage of problems in front of me. Do I just apply AI and machine learning and data science to all of them, figuring out this problem? Or do I have a starting point to say which one would fit into it when I have a mirage of problems in front of me? Where do you think we are heading towards? And where do you think actually should I start? Professor?
So, I mean, I would again be inclined to say that this should not be answered in principle, but must be more demand pull, right? Like, so you start by saying, every problem should be addressed in the most logical way, and the logical way might involve data-driven decision making. So I'm still finding it hard to say it as a pick a subset or which pick the top X kind of an approach. Instead, I honestly see it as, why don't we start with every problem and say, what does it take to solve this problem? And I'm sure that many of them would be a data-driven solution, and therefore AI organically comes in. I would also really push against this notion of, is AI mature enough to solve this problem? I honestly feel that the way we are using the words AI, at least, which has broadly become a proxy for data-driven decision making, if you're not able to solve it with data, then maybe you're not asking the right problem. I mean, you're not framing the problem statement correctly. I'll give you an example. You might very well have this view that an AI engine should be able to look at an image and identify cancer, right? And there you can kind of sit and debate as to whether the technology is there or not. But for whatever reason, and first of all, by the way, the technology does exist on many of these things right now. Even if it is not, there is no doubt that if there is some amount of image recognition, there should be some program in there that is helping a doctor. Either some of these get looked at twice by two different doctors, some of these get put into two separate bins saying, look at these carefully, look at these lightly. So there is definitely some logical way to weave in just completely in a demand driven way. So that's my 2 cents.
Understand. No, makes sense. Sheila, there's a follow-up to what the point you talked about, reproducibility. The question, which I think even I had it in mind, the review process in data science, should it be as rigorous in other areas of science? If it's not, would it be less credible? I think it's a fair follow-up point to what you said. What is your take on that before we go to the answer to this question, Srinath?
Yeah, so I think like any other business decision, this too is a trade-off. So in the context of the problem, we'll need to identify what is the impact or risk if there is an issue with the model which hasn't been caught during peer review, and trade it off against the investment and effort which a peer review does take. So if and this depends on the nature of the project as well as the stage of the project. So if it's an early stage project, and let's say which is intended to influence business strategy, then the risk of being wrong in that can be quite high. The impact can be quite high. So in that kind of a case, a peer review and the time and effort taken for it is absolutely worthwhile. But if you're building a data science based product like detecting health conditions from voice samples, which let's say you have an initial adopter pool of customers who are willing to try it out, then it's probably the impact is lesser. You'll quickly iterate to find out if there are issues. So in that case, maybe the internal peer review can be a bit more relaxed. So it entirely depends on the business context, the potential impact of some errors creeping in, and those factors.
I understand. No, makes sense. So let's go back to the point which I was saying. A mirage of problems in front of you, artificial intelligence, data science, machine learning as an instrument. How would you start? Where would you start? What's your view?
Yeah, I mean, completely agree with Professor here. We should use whatever tool is required to solve the problem. And I mean, just sorry for being a bit philosophical here, but the way humans operate or take decisions, I think, is typically based on data. I mean, even our intuition tends to be built by data of similar situations in the past. So if you're trying to do artificial intelligence or trying to be intelligent like humans, like Professor said, eventually it will probably come down to data-driven approaches. And so I think eventually it will be AI which gets adopted, but that shouldn't be our thought process. Our thought process should be what are the techniques that can be used to solve a problem, and then we'll see where it goes.
Vineet, your view?
Yeah, so like everyone, I would also say it's a very open-ended question, but if I had to answer it from a practical angle, like when we are faced with this, there are many problems, like in some of the products, there are many problems that could be solved. Which do we start with? So of course, you would first see, is data science really needed for all of those, or could you just use rule-based systems for some of these? And once you have identified those that need data science, you could pick the low-hanging fruit. So I'll give you an example. So there was a product that used to monitor the usage of energy, water. So you could. So this product collected a lot of data, and a lot of things could be done. But to begin with, you could just take a low-hanging fruit. So since you have collected data, you have monitored that, now it's natural to add prediction capabilities. So that adds value to the product. You already have the data, and it's likely to work because your energy and water usage will have consumption based on whether it's office hours or weekdays or weekends. So there are higher chances of success. It has added value, and you already have the data. So you could attack them first, which is what we did, and then you could move on to more complex things like detecting anomalous usage in the usage of water and energy, and so basically these are the categories of problems that have a high value, but maybe more complex to solve.
Okay.
So that would
Very
be a
nice.
simple categorization of which ones do you take first, and then how do you move ahead. But this is in very layman's terms. In reality, it's actually very open-ended question, and no straightforward answer can be given.
I mean,
Okay.
just one thought to add there, Balaji, if you have a minute. Like, you know, there is a lot of, again, tendency to postpone data science projects because we feel like we need to put the architecture in place, we need to put the pipelines in place. And this kind of dovetails with your question earlier also, right? Like, and somewhere, again, I guess perhaps this is a bias, but one of the biases that I have is that you're better off in trying things in an iterative way, where you try the 101 algorithm with the 101 data, and then you see what results are there, and then you improve on the data quality, you improve on the architecture, you improve on the algorithm. And perhaps that is a reasonable way to go about trying data science on multiple projects and then scaling up, rather than in principle, in a non-data driven way, deciding what to apply data science to and what not to apply data science.
Okay. Okay, I'll wrap it up with one question each. Would you, and again, it's a novice question, but a question which is coming up from many people, many quarters. Would you prefer going a rule-based system or an AI-based system? And if so, why? Srinath?
So if I'm able to use an AI-based system where I have reasonable visibility into the model's predictions, or what is commonly referred to as explainability, I would prefer that. If that's not possible, if it's a complex problem where explainability is difficult, then I would try for a rule-based approach if possible. And finally, if neither of these are feasible, then we'll go with advanced AI models which lack explainability as well.
Vineet?
So I would want to go with the data science-based systems. In I would say most cases, because rule-based systems have these traditional limitations. You need to keep updating the rules, changing the code, and it doesn't get better on its own, which is the case with machine learning, data science-based systems. So they keep getting better as you give more and more data. So, but yeah, there could be situations where rule-based make more sense, where probably they might outperform data science-based systems. But I think in most cases, I would vote for data science-based systems.
Professor, last but not the least, to you.
Yeah, no, I kind of agree with what Vineet said in the sense, and I guess what also Srinath was saying. I mean, I see the rule-based system as the bare minimum. I mean, you have to have a system, right? And a system that is not data-driven is a rule-based system. So you're starting there, and almost anything that you do is an improvement upon that. So maybe a more harsher version of what Vineet so nicely put. Perhaps I could say that if your database system is not improving upon the rule-based system, then you're doing something wrong, right? Because the bare minimum was the rule-based system. So maybe you can stick to it, and certain places selectively bring in the database system where the data is good, where the algorithms are good, and you have to, by definition, see an improvement in performance.
But Professor, on that note, what would you see? I mean, because data science is so dominant about data, what development model would you look for, or technology stack would you look for? Open source, proprietary, something off the shelf? How does it work?
So the way it works is, I mean, again, this is my take, partly in academic and partly in industries. See, almost the latest algorithms, even the ones that have the best performance, are available as code bases online. Like, I mean, a lot of these really good conferences require you to publish the data, the source code, and so on. So while you might not be able to process the most complex algorithms, getting access to them or replicating them from a paper is not too much rocket science. And almost any software that comes today comes with these packages. So while it is great for academic interest to focus on algorithms and improvement on algorithms, in industry, I don't see that as the need of the hour. It is instead the fact that almost no real world problem will be a toy problem where you can pull the algorithm off the shelf and apply it. So a huge part of the challenge, and therefore a huge part of the data scientist's contribution, is to really understand what the problem statement is, understand how the algorithm works, and how you can customize it to fulfill the requirements of the business. And that to me is really challenging, because you need to actually get into understanding the idiosyncrasies of the data, the problem statement, and so on.
Interesting you say that. So with the luminaries on the call, I think it would not be nice on my part to just let you go easily, but request you to take a bet on where this is all heading. Where is all this AI heading? What are new trends which are happening? And maybe this is for a detailed thing in another call, but as a prelude into the next webinar. Where is the whole AI, data science, machine learning heading with regards to trends, with regards to the progress it is making? Your views quickly, because you guys, I'm sure, are part of a lot of communities, are exploring a lot of things while you're trying to enhance yourselves and do some research. So what do I get to hear from you guys as to what's the bet on this now? Professor?
We are not going to see an AI winter like we saw in the past. So I don't know if you're familiar. AI has had a history where there has been a lot of hype and nothing came out of it, so it receded in its own. I don't think that's going to happen for multiple reasons. I don't think it's going to happen because the kind of compute we have now is very different from back then. The kind of environment we live in, that is, we are a lot more on digital platforms right now, whether it's not just IT, but whether it's finance or whether it's HR or whether it's social networking, they're all happening, or commerce, for instance, is all happening on a digital platform as opposed to before. So no, one, I don't think it's going away. Two, I would be willing to wager that it's going to become something like what IT became. Like, in a sense, sure, there might be quarters of hype, but that does not mean it ever goes away. Right? Can we say right now IT has gone away? No, right? It's bread and butter and it exists. Sure, could we have pointed to some pockets, some startups, some market valuations which were a little bit more than they should have been? Perhaps. So I think that's what's going to happen to AI in some sense. It's not going away anywhere. It's going to become the backbone and of industry and so on. Perhaps there might be some hype and some corrections, sure, but that's my 2 cents.
Vineet, your view, your take?
Yeah, so AI we are already seeing is applicable to almost every business. People have already applied it, or they are curious and they want to apply it. So it's definitely becoming more and more ubiquitous. And as far as the trends that you asked, what trends we are currently seeing, so there is a lot of interesting thing happening on the NLP side. A lot of unstructured text exists on the web, and people are trying to solve really interesting problems. And different companies are coming up with these new techniques like BERT and techniques that we have seen recently, which are giving very amazing results. They look promising. Reinforcement learning is being adopted in a big way. And one important thing I would want to mention is democratization. So data science till now was data scientists used to proudly call themselves data scientists because somebody called it the sexiest job of the 21st century. And so, but now there is focus towards democratizing it. Things like AutoML AI services are coming up, which people with even less knowledge of data science, even those kind of people can apply data science now, where these libraries do all the complex things uh, and give a very abstract interface to the user. And in some cases, we have already pre-trained models, and just people can call them as services. So that's a trend that we have seen picking up recently to enable non-data scientists to apply data science.
Thanks. Srinath, last but not the least, your view, your take?
Yeah, I think democratization of data science, particularly in the last 2 years, has been impressive. I think many software engineers and people from various backgrounds will start applying AI techniques in ways we haven't imagined so far, probably. Personally, there are two areas where I'm very curious and interested in. One is human in the loop reinforcement learning, which I think Professor Vinit mentioned earlier. They're very interesting research studies of using that in clinical diagnosis and those kinds of settings. I'm really excited to see how it gets actually evolved to being applicable in the real life. It's still in kind of the research phase, I think. The other is generative models like GANs, which are already pretty mature, but haven't yet seen wide adoption or use cases in businesses or enterprises. So I'm looking forward to see interesting use cases where generative models can be used increasingly.
Understand. Very good. Thank you, gentlemen, for the call. Very interesting. Thanks for taking the time. Audience, sincere thanks for participating and for responding to the 2 poll questions. Very useful data points which came up from there as well. Professor Nandan, always a pleasure talking to you and hearing from you. I hope to live up to some of the things which you talked about today. Srinath, thank you as always for your research mind and your insights, both as a data scientist as well as enterprise level architect, which you framed it quite well. And Vinay, for your enthusiasm in trying to make me understand what does data science, AI, and machine learning mean, and to figure out what are things which I should look for when I pursue on this particular road of AI ML. Thank you so much to the audience, wherever you are, for joining this call. Thank you all. Bye for now. Have a good day or a good evening. Talk to you soon. Bye for now.
Thank you.
Thanks, Balaji. Thanks, everyone.
Thank you, Balaji.